webinar topic, which is, again, maximizing your investment in Windows 10 with DirectAccess and the Kemp LoadMaster. Before we get going, I do want to do just a brief introduction for those of you who are not familiar with who I am. My name is Richard Hicks. I am an independent consultant and a Microsoft MVP, or Most Valuable Professional, awarded in the enterprise security discipline for the last 7 years. I've been working in the IT field for about 20 years, coming up on 20 years now, and have spent a great deal of time during those 20 years deploying edge security and remote access solutions using Microsoft technology. So I'm uniquely positioned to talk to you about today's subject. If you'd like to learn more about me and about what I've been working on lately and what I'm up to, certainly I would ask that you just visit my website, which is directaccess.richardhicks.com. The agenda for today's session, it's not a real long and complex one, but one that has a number of topics that I want to touch upon. The first is obviously just a quick introduction to Windows 10. We'll follow that up with a brief overview of DirectAccess, kind of compare and contrast with the VPN, and show you DirectAccess in action, so you get a feel for what that's like. We'll talk about some of the enterprise features and capabilities that are included with DirectAccess natively. We'll talk about how Windows 10 and DirectAccess really complement each other. We'll also spend some time, of course, talking about how the Kemp LoadMaster load balancer makes DirectAccess even better. And then we'll wrap it up with a quick, hopefully a quick Q&A session. Hopefully we'll have plenty of time for questions and answers. What I would suggest is that if you do have questions, please just put them there in the Q&A window, and we'll get to them at the end of the webinar. Any questions that we don't get to, of course, we can certainly follow up by email, or you can reach out to us directly and let us know what those questions are. So getting started, a little bit about Windows 10. So of course, if you're not familiar with Windows 10, it was released just late this summer, July 29, 2015. Microsoft released Windows 10 to the general public. Of course, many of those of us in IT have probably been using Windows 10 much longer than that. I certainly was one of the early adopters and one of the first ones in the pool with regards to Windows 10. And it's a great operating system, thoroughly enjoying it myself. Many of you are as well. At a recent Microsoft event, Microsoft indicated that Windows 10 has already been deployed to over 110 million devices. And this is pretty staggering considering that this has been out for, what, less than 3 months. It's pretty impressive. Microsoft also indicates that about 50% of their Microsoft managed clients, these customers that they manage their infrastructure for, are either already moving to Windows 10 or are planning a migration now. So the adoption rate for this operating system has been pretty quick and pretty hastily done. It's definitely a good thing. I think there's a lot of people that could benefit from the new features and capabilities that are a part of Windows 10. Now, during this webinar, I don't want to focus on the deep intricacies of Windows 10. There's all kinds of new features and capabilities from user interface improvements, performance and security and things like that, provisioning and whatnot. I don't want to focus on that. Really, the goal of this webinar is to address those customers who have, are still running Windows 7, skipped to Windows 8 migration, and are now planning a migration to Windows 10 and looking to maximize their investment in their Windows 10 rollout. Of course, I could think of no better way to maximize your investment in Windows 10 than using DirectAccess. So if you are not familiar with DirectAccess, DirectAccess is a next-generation remote access. It's a new type of remote access. It's a little bit different than VPN. We'll talk about that in the next slides in detail. It is a part of the unified remote access role that is included in Windows Server 2012 R2. So unified remote access includes things like traditional client-based VPN, site-side VPN, the web application proxy. The DirectAccess role is a part of that particular feature. DirectAccess provides seamless and transparent, always-on, bidirectional, secure remote corporate network connectivity, and the bidirectional component is, in my estimation, one of the key differentiators between these two technologies. DirectAccess differs fundamentally from VPN in a variety of different ways, and once you see it in action, I think you'll get a sense of what I'm talking about. But I think the best way to do this is really to kind of compare and contrast direct access and VPN. So VPNs, of course, are user-initiated. The user has to make a proactive decision that they need to access the corporate network to access applications or data on premises. So they have to initiate this process. Of course, this is a manual process. They have to launch the VPN client, put in their credentials, hopefully put in their one-time password, and the whole process is rather cumbersome, and the user experience is generally pretty poor for the user population. You know, us IT administrators are probably more used to it because we've been using it for longer, but again, the general user population finds the VPNs particularly painful in most cases. By contrast, VPN is very simple and easy to use. It is computer initiated, so the connection and the authentication happens in the background. It happens at the machine level. It's performed automatically, so there's no user interactivity required. The direct access client will connect to the direct access server and have corporate network access anytime a direct access provision client is connected to the internet or has an active internet connection. It is extremely easy to use, and I think the best way to do that is really to kind of demonstrate what direct access looks like in action. So let me jump over to a direct access client that I have here. This client is been provisioned for direct access, and we can see that by, let's see, I'll take a look at a couple of things here. So as you can see, do quick config. What you'll see here, of course, is that I'm on the public internet. I have a public IPv4 address assigned from my ISP, and here I can get to the public internet. But at the same time, I can also get to on-premises applications in the same manner. Also, the nice thing about direct access, of course, is that it's very easy to use, as I'd stated. As you can see, I'm actually getting to this resource by its single label host name. So I didn't have to type in a different URL. If I have a shortcut on my desktop, so I have a shortcut on my desktop to this application, the user can just double-click on the shortcut, and they're already connected, and they're good to go. In addition, for example, let's see here, I have access to my home drive. So I have access to all of my data that's mapped to my home drive. I would have access to any on-premises data and applications that I would have if I was in the office. By the way, just so that you know that I'm not pulling any strings on you here, you'll see there is no VPN connection. As a matter of fact, so you see there's no VPN connections, but what you will see is that this client has been provisioned for direct access. Direct access does show that it is connected. In this case, this particular demonstration lab features a direct access multi-site deployment, which we'll talk about a little bit more later, but what that means is that I have geographic redundancy implemented. This is a demonstration lab that's set up with Kemp LoadMaster load balancers. They're providing both local and geographic redundancy, and so you can see that I'm connected via multi-site direct access, but I'm connected to this particular entry point. Now, of course, the user experience is awesome from a direct access perspective, but there's also some significant advantages from an administrator's perspective. So you as the IT admins get some tremendous benefit from a direct access deployment as well. As I had stated earlier, direct access is bidirectional. I think that's what really sets direct access apart from traditional VPN. So, for example, as an IT administrator, if I needed to provide, if I needed to manage this provisioned desktop and it's outside of the office, it's connected via direct access. As long as it has an active internet connection, I can manage it remotely without any user interaction. So, for example, let's say I want to, for example, I want to use or look at the event logs. I can just simply enter in the host name, and you'll see that I'm connected to this device, and I can manage it exactly as if it were on my corporate network. If I need to get to, for example, maybe I'm doing some forensic work on this. Maybe this unit's been compromised, or maybe there's some indicators of compromise, and I want to look at Windows event logs. I can certainly do that. Anything that I can do to this client inside the network, I can do when it's available outside of the network. For another real common use case for direct access is just simply doing remote desktop sessions. So, for example, I can go to I can actually RDP into this client. So in this case, I may want to manage this client remotely. For example, I may want to connect via RDP to provide remote assistance. I may want to help an end user with an application. So here, as you see, I've just RDP'd directly into this desktop. And again, this is the same client machine. You can see that it has the same IP address. This is the same machine. So I've RDP'd into this, and I could help this user with an application or do some troubleshooting remotely. So tremendously, tremendously beneficial from an administrator's aspect as well. And by the way, for those of you, for the astute observer there, you'll notice that, actually let's jump back to that, because I know this will come up as a question later. So I'll try to fix that right now. One of the things that you'll notice here is that this machine, this is my managed machine. It actually is on my private network. It is in the corporate LAN, and it does not have IPv6 running. In this particular scenario, I've been able to enable manage out using multi-site with external load balancers, all of which are not supported scenarios, but they do function and they do work using bespoke configurations. If you have any questions about that, ask me later, and I'd be happy to explain to you how we implemented that. So that's DirectAccess in action. You can see that there's a number of advantages using DirectAccess. From an end user perspective, you saw a really streamlined user experience. Familiar access, which I think is tremendously beneficial for the non-initiated end users, the non-IT end users. They access resources outside the network in exactly the same manner as they do inside the network, which of course results in much better productivity, less fighting with the VPN, more working, more access to applications. From an administrator's perspective, of course, if you do, the graphic will be familiar to you if you are managing SCCM. You know that managing remote clients can be challenging. They don't ever check in with your SCCM servers or don't check in frequently enough, and so they fall out of management. Direct access clients with ubiquitous access are always managed, and so with that comes improved security and compliance, and ultimately reduce support costs. So with regards to direct access and the enterprise capabilities, like any Microsoft workload, Microsoft does include enterprise features to help large customers deploy this technology. Direct access does provide support for local redundancy. In other words, we can implement load balanced clusters, which make for a solution that becomes easier to scale and, of course, eliminates a critical single point of failure. It also supports geographic redundancy, or direct access multi-site. What this means is that we can deploy direct access entry points in multiple physical locations. So if you have an organization that has data centers in multiple physical locations or spans geographies, many of our large enterprise customers certainly fall under that. Then we can deploy multi-site direct access and deploy those entry points for geographic redundancy. Modern clients support automatic site selection and transparent failover. Unfortunately, Windows 7 does not support that. That would require Windows 8 or Windows 10 to support those features. And again, that brings us back to the point of the webcast today, is that direct access and Windows 10, for lack of a better term, are just genuinely better together. They complement each other very, very well. So Windows 10, of course, provides full support for all of those enterprise features. So you don't get the things like automatic site selection and things with Windows 7. Windows 10 does support that. It also supports transparent failover, meaning if I'm connected, if my Windows 10 client is connected to an entry point in Los Angeles and that entry point goes offline for some reason, perhaps an ISP outage or something like that, my Windows 10 client will then transparently fail over to a New York site or one in Europe or something like that. Also, Windows 10 and Direct Access supports offline domain join. Now, offline domain join has been with us for a little while, but only in Windows 8 and Windows 10 clients does it support the provisioning of direct access policies and settings. And so with Windows 10, I can actually remotely provision a client have it join the domain, and give it all of the direct access settings so that the user can log on the first time and still connect to the corporate network. So in terms of provisioning, offline domain join with Windows 10 and direct access support is tremendously valuable. So let's take a look at some of the features and capabilities that Kemp adds. So direct access is a fantastic remote access solution. Windows 10 makes it even better. I think adding the Kemp Load Balancer really makes it awesome, and we'll demonstrate some of those things here in just a few minutes. With the Kemp LoadMaster, of course, you get much better load balancing. So for example, we talked about local redundancy using clustered arrays. With this, of course, Microsoft uses Windows Network Load Balancing, or NLB. NLB suffers from kind of a fatal flaw in that it is broadcast-based. The array members, the nodes in the array, communicate with each other using heartbeat messages, which are broadcast every single second. 1 second is a broadcast heartbeat. This is obviously a very poor design and one that has negative scalability as well. It just doesn't scale very well. As a matter of fact, as you add more nodes to an NLB array, the less effective it becomes. So it has some real challenges and some real point of diminishing returns that you can approach pretty quickly. Network load balancing in Windows also suffers from poor visibility. There's a real lack of visibility into how traffic is being managed, how it's being handled, and so forth. And there's no granular control with NLB. As a matter of fact, I like to tell folks that NLB, or network load balancing, really isn't load balancing, it's connection distribution. So there's only a single load balancing mode, and that is round robin. So a connection comes into the virtual IP address, it is simply distributed to the next node in the array. There is no concept of what load the particular array member is under, or even the health or the status of that particular array member. As long as it responds to that heartbeat broadcast, the NLB believes that it is, it's prepared to handle that traffic, and it will send those connections as well. Again, no concept of health or state or current load. Now, using the LoadMaster, of course, is an infinitely better way to provide load balancing for direct access. It is IP-based, of course, so we don't suffer from that broadcast-based limitation. Much better visibility and much better control over that traffic, so we can, at a much better level, control access and control traffic distribution, and do that in a much more efficient manner. We can use the LoadMaster to improve upon the native geographic redundancy features. So that site selection process that I told you about, the native site selection process in Windows 10 is very rudimentary. Basically what happens is the direct access client using Windows 10 is aware of all entry points. And let's say, for example, we have an entry point in Los Angeles, another one in New York, and another one in Amsterdam. The direct access client, regardless of where it is in the world, once it comes online, and once it determines that it will need to make a direct access connection, it will actually send an HTTP GET to each of the entry points. The entry point that responds with the shortest or the smallest RTT, or round trip time, the one that responds the quickest, is the one that it will connect to. The challenge with this, again, is it's a bit oversimplistic, and it lacks some fundamental things like location awareness. So there is no concept of geographies to the native site selection. Doesn't lack any entry point status details. So, for example, again, very similar to NLB, it doesn't know the health or the load that current entry point is under. We can use the Kemp LoadMaster's geographic load balancing capability to implement a GSLB solution for that. So with the LoadMaster, we provide much more intelligent traffic routing amongst data centers. It is location aware, so it understands geographies and things like that. And of course, the LoadMaster Geo is aware of the load and the configuration status of that particular entry point. So it provides much better and much more effective and efficient geographic redundancy for direct access clients. Finally, of course, we can use the LoadMaster to make some improvements and enhancements to our supporting infrastructure. The network location server, or the NLS, is a critical DirectAccess infrastructure component that's used by DirectAccess clients for inside-outside detection. In other words, a DirectAccess client, when it comes online, has to determine if it is inside the network or outside of the network. If it's inside the network, there's no point in connecting via DirectAccess. It's already on the LAN. If it's outside the network, of course, it will need to then connect via DirectAccess. Well, the NLS is really nothing more than a web server with an SSL certificate, and if the DirectAccess client can contact the NLS, it assumes that it is inside the network. If it cannot connect to the network location server, then it assumes that it is outside of the network. So it's important that this resource be highly available, because if the DirectAccess network location server is offline, remote or field-based clients won't be affected. However, the DirectAccess clients or clients that are provisioned for DirectAccess that are on the LAN at the time, if the NLS is not available, they may detect that they are outside, erroneously of course, and then attempt to connect via DirectAccess, which results in a variety of problems, none of which are very good. So we want to ensure that the network location server is highly available. Now, commonly, customers will just deploy a pair of IIS servers and enable NLB, but we still have those same fundamental shortcomings with NLB as we talked about before. And of course, using the LoadMaster load balancer provides intelligent traffic management and load balancing for our NLS as well. We can even leverage GSLB feature, the geo feature of the LoadMaster, to provide location awareness for the network location server. The network location server is an interesting component in DirectAccess, in that you can only provide a single NLS URL for a given DirectAccess deployment. And if you have a large internal network that spans multiple physical locations, oftentimes the NLS becomes a single point of failure, even if it's redundant in one location, because you may have challenges with WAN connectivity between data centers or between buildings where users reside. So you can actually use the geo for that to address that particular challenge. Finally, you can actually use the LoadMaster for the network location server. It actually can serve or replace the network location server itself. So that's tremendously useful. And of course, the idea here being that it reduces infrastructure requirements, so I don't have to spin up web servers, IIS servers, which again consume resources, consume licenses, things like that. The LoadMaster, of course, is going to be much more resilient and much more highly available, requires less servicing than certainly a Windows server. So there's a lot of there's a lot of significant advantages to using the LoadMaster for the NLS, and as long as your LoadMasters are redundant, which of course they fully support that, then your NLS is redundant as well. So I want to take a look at the Kemp LoadMaster in action. What I want to do is demonstrate that in my environment here. And to do that, I'm actually going to use my DirectAccess client. So we're basically going to show off DirectAccess a little bit more here. Let's see. So I have to connect back. This is my client that I connected to remotely with RDP. So I'm going to log back in. Maybe if I could type my password right. There we go. Great. So in this case, again, still connected remotely, we're going to go ahead and manage our LoadMaster remotely. So let's log in. Great. So here you see the LoadMaster, and again, as I mentioned at the outset, this LoadMaster is already configured in my environment. We're actually using it and connecting through the LoadMaster on this particular client, managing our network remotely. You will see here that, of course, I have a variety of virtual services. Here I have provisioned DirectAccess load balancing in one of the entry points, and I have a couple of real servers there. This is my network location server as well. So let's take a look at these configurations. So go to View Modify Services, and we'll modify this. Take a look at this. Deploying direct access with the LoadMaster is not terribly difficult, by the way. It's really not much more difficult than deploying a LoadMaster for a traditional SSL web server. As a matter of fact, it's actually easier because with the LoadMaster, we don't perform SSL termination, so we don't have to enable acceleration. All we need to do is forward that traffic. There's no reason, by the way, to do SSL termination because Windows 10 clients actually don't take advantage of SSL encryption. They actually use null encryption to reduce the protocol overhead. The traffic within an IP HTTPS tunnel for direct access is actually encrypted IPsec traffic, so there's no reason to double encrypt that. So here you'll see that we have a number of options that we've set. Here, since the LoadMaster is on the public internet with a public IPv4 address, I'm using source IP address for the persistence. If it's behind NAT, there's obviously no need to do that because the source IP address would not be the original client, it would be the NAT device. With regards to real servers, again, real servers are configured with the health check to check the IP HTTPS URL. We're using HTTP 1.1, so we have to provide the host header and so forth. And so this gives us a nice view of how traffic is being delivered and the health of the particular direct access servers. I have global load balancing enabled as well for this. You'll see that I'm using proximity. So this is using a feature of the geo that allows me to, again, this is much better than just using round-trip time measurements between servers. This gives the client, or gives the LoadMaster the ability to look at the client's source IP address and then more effectively distribute that traffic to the nearest, physically nearest entry point for the particular entry point number for that client. Last thing also, let's look at, forgot to show you the network location server. As I'd mentioned, the DirectAccess NLS is available, and I'm actually using that for the NLS here. I can't browse to it to show it to you because I'm on the outside, so the NLS is not available to me. But fundamentally, this is just nothing more than it's actually implemented, as you saw, as a redirect. If we look at this, what we've done is we've set up, there's no real servers for this because the LoadMaster is going to respond. But if we look at this, we enable SSL acceleration, we assign our SSL certificate. It's critical, of course, that the NLS certificate match the host name that we use in the NLS configuration in the direct access server. And then finally, if we go to advanced properties here, what we have done is we've set up the option to respond with an error code. Now, oddly enough, this is a bit of a misnomer here, but it is what it is. The error code is 200 OK. What we're doing is responding to the client's request for the NLS URL with a 200 OK. That's it. That's all that the direct access client needs to see. It sends this request as long as the certificate matches and the name matches and the certificate's trusted and the certificate is valid and the web server responds with the 200 OK. Then that's all we need. So fundamentally, all we need to do. This, by the way, is available as an update to the LoadMaster. Maybe Bargov can speak to that a little bit later, but there's an update that was released recently for the LoadMaster. So if you're looking to implement this, then you can, if you don't see this option in this list, if 200 OK does not appear in your list, you don't have the latest update to a LoadMaster, so you may need to update the software. I'm running 7.1.28b, so just a heads up on that if you don't see that. Let's see. So at this point, you know, unfortunately, due to the kind of nature of the webcast, we don't have time to go into a full deep dive into how to configure each and every one of these services. I can kind of demonstrate for you what it looks like, but fundamentally, I can't. I just don't have the time to go and give detailed instruction on that. The good news is, of course, is that DirectAccess. There is a direct access deployment guide available from Kemp, authored by yours truly, and it includes a lot of detailed information and prescriptive guidance for you to implement the Kemp LoadMaster with DirectAccess and do so using an advanced configuration. There's a lot of detail in this. It tells you how to use it, and of course you should be able to follow that documentation and be able to deploy DirectAccess with the Kemp LoadMaster in all of those scenarios: local redundancy, geographic redundancy, and so forth. You can find the guide at bit.ly/KempDAGuide. That's probably the best URL to find that. You can download that deployment guide. It's freely available. You don't have to log in, and you can find that information anytime you like. Now I just want to turn it over to Bhargav from Kemp Technologies to talk a little bit about the Kemp platform in the company. Bhargav?
Thanks, Richard. All right, so I do want to just give you a quick overview if you're not very familiar with what the Kemp technology is about. Richard, I think you might want to keep the slides and we can just run through the slides. I don't actually have the slides from here.
Will do. Let me know if you need to advance.
Just waiting for slides to come back up.
Sorry about that, guys.
Oh, I'm sorry. Did you switch that? Sorry, Liz. Can you make me the presenter again, Liz, or do I have to do something?
Yeah, you are. You can just
put
the slides back up.
Okay. Sorry, guys, not finding that right now.
Not a bad thing when we're running at a quite fast pace. It's a good breather to have. And Richard, we have quite a few questions that are coming up. So what we'll do is, once I'm done with a brief overview of Kemp and Kemp's products, I'll read the questions off to you so we can answer them.
Very good.
So yes, I see the slides now. I hope everybody else sees the slides. I did want to give you a quick overview of what Kemp is, what Kemp does, what offerings do we have. So Kemp as a company, we have been around since year 2000. We have the offering that's all about load balancing application delivery. So we are best at what we do. We provide high availability, scalability, what you expect from a best-of-breed load balancers and application delivery controllers, the intelligence, the load balancing, the standard features of load balancing as well, of course. When it comes to company itself, we have more than 26,000, and that's a couple months older number, I believe. We have more than that now. The worldwide customer deployments. Since we are a channel-based company, we sell through channels. You can go to our Kemp Technologies website and put in your credit card to buy a product. And having said that, we have more than 1,000 channel partners, which gives you a choice of who you want to purchase it from, regardless of where you're across the globe. The staff growth, the company growth, both have been very impressive year over year for last few years, which is also always great to see. And I'm keeping one more impressive measure for later. When it comes to offerings, what you get, most people are used to seeing an appliance that you get, you put it in your rack and you configure it and forget it. That's the rightmost ADC hardware appliances, as we call the gold boxes. We started with that and then expanded into other offerings as we go left. Starting with the virtual appliances. The virtual appliances offer you ability to run the fully functional load balancer in your virtualized environment, whether it's VMware, whether it's Hyper-V, or whether it's any of the other well-known virtualization platforms. You can have a fully functional load balancer for your production, test, and lab environments. Bare metal ADCs allow you to use your existing equipment such as Dell and HP servers. For an example, we do support more server manufacturers to use our load balancer as an operating system on the bare metal ADC. There is a misnomer there that people assume that we are basically running it on top of virtualization. But when it comes to bare metal, no, we do not. We literally run as an operating system right on top of the hardware. So we squeeze out as much as possible out of the underlying hardware, not adding any additional overhead of virtualization when it's bare metal setup. And then the last but not least, with proliferation of Azure infrastructure as a service, Amazon AWS, VMware vCloud Air, we have offerings that allow you to continue to use best of our features in the cloud platform as well. So when you use any of those cloud offerings, and when you need the advanced functionalities of layer 7 load balancing, you can use Kemp's offerings. Richard, if you advance the slide one more. How do we fit into Microsoft offerings? When you look at all the different products that Microsoft offers, DirectAccess, remote desktop services, IIS, ADFS, Dynamics and SharePoint, Exchange, and Skype for Business, all of these on-premises workloads require load balancing of some sort. And Kemp works with all of those workloads. We have deployment guides available from our website for each one of them. And when you have primary and secondary sites, or when you have multiple geographically separated sites, you can use our geo-enabled LoadMaster to provide the proximity detection to distribute the traffic smartly and intelligently. And in case of warm standby sites, you can also use the same geo functionality to decide when the primary site is not available and to redirect traffic only in those cases to the secondary site. For cloud offering, Microsoft has quite a few workloads that are certified to run in Azure. The ones highlighted are only some of them. We do work with all of them in Microsoft Azure. You can deploy our LoadMaster from Marketplace directly. And the interface is familiar, the functionality is familiar, and I wouldn't say exactly same, but similar for the reason that Azure's networking stack works a little bit differently than the way you can configure it in your on-premises data centers. So keeping that in mind, we still work in the same fashion, same ways to deliver your layer 7 functionality of your existing applications running in Azure. And that gives you quite a bit of flexibility there. We can go to next slide, Richard. And so as we were talking about the impressive growth that the company had, we have also been keeping up with the challenges that we have in our field by proving not only that we can execute on the needs of the market, the workloads currently, but we also have the vision to sustain the requirements of changing landscape as new technologies come into the market, as new applications require different ways to handle application delivery. And that lands us this year into the visionary segment, the only ones to be in that segment, in fact, for this year. And we have been on Gartner Magic Quadrant for a few years now. So this actually gives you comfort of knowing that the company is known, company is well run, and it can deliver both on your needs today and can sustain the growth by providing you the best of what's to come tomorrow. And with that, I think, Richard, the next one is Q&A. Is that right? Oh, the resources. I do want to point out this is a very handy slide for those who are looking for immediate access to the guides that we have for the resources. DirectAccess deployment guide, like Richard mentioned earlier, ADFS, remote desktop. And the last link I do want to draw your attention to is the free load balancer that you can use in your test, lab, training, and even in production if the restrictions we have on the free LoadMaster meets your requirement for the production. There are some requirements, but I invite you to check that website out and at least give it a try. And with that, I think, Richard, the next one is coming up is Q&A. If you don't mind just keeping the resources slide up while we go through Q&A, it'll give people a chance to grab the links there. And so, Richard, when you're ready, I'll just start with the Q&A we have in the list.
Great, yeah. I'm trying to pull it up right now.
No, I can just spell it out for you. And
sure.
So the first one is the DirectAccess traffic encrypted? What about man-in-the-middle attacks, and how well has this been tested on the security side? Question from Vijay.
Lots of security questions. So let's take that one step at a time. So yes, the direct access traffic is encrypted. Direct access communication is encrypted using IPsec. So these are standard, commonly deployed, encryption technologies, AES. And SHA-2 and things like that. So pretty standard stuff in terms of protection. The protection is very solid. A common, or the most common, the most recommended direct access deployment uses certificate authentication. So in terms of protection, the clients and the servers have to have certificates issued by the internal private PKI. And of course, the user the machine has to have a computer account in Active Directory. The security of the solution is actually, in my terms, pretty exceptional. It is much more secure, and you have a much higher level of assurance that direct access clients are valid because of the, not just any client can connect to remote access using direct access, unlike VPN, right? So the assurance level is high. All the traffic is fully authenticated and encrypted. In terms of man-in-the-middle attacks, they are theoretically possible, but the payloads. So the challenge with that is that some folks will think that if I attack the IP HTTPS tunnel and in an attempt to break direct access communication, I may actually be able to do that. I may actually be able to impose a man-in-the-middle attack on that, in theory. However, the payload being IPsec encrypted is going to yield the attacker communication that's going to be basically impossible or next to impossible to decrypt. So, in other words, without additional information like private keys. But fundamentally, the solution is very secure. It's been deployed by some of the largest organizations in the world, and is a very, very secure solution. Certainly, much more secure than typical traditional VPN, client-based remote access VPN.
Cool. Next question is from William. Is direct access available with Windows Phone 10?
It is not. So direct access is available to Windows desktop clients. It is available for Windows 7, Windows 8, and Windows 10. And it also has to be the enterprise SKU. So it is available for Windows 7 Enterprise, also Windows 7 Ultimate, and also Windows 8 and Windows 10 Enterprise Edition. It is not supported on any other SKU of Windows. So in other words, Windows 10 Professional, for example, is not supported as a direct access client, not available on the Windows Phone as well. There are additional remote access technologies that are a part of the unified remote access role, like client-based VPN, so you can still leverage the underlying operating system, Windows Server 2012 R2, to provide secure remote access. You just have to use a different technology than direct access.
All right. The next one from Mark is if direct access clients use public IP, how do we set firewall rules to allow access, and how is routing done?
So that's pretty straightforward. So the direct access uses a public IP address. Direct access client uses a public IP address. However, that public IP address is really just for the transition tunnel. It's important to understand that direct access uses IPv6 for client-to-server communication. So all of the traffic between the direct access server and the direct access gateway is IPv6, and it is IPsec encrypted. To get that traffic over the public IPv4 internet, which is more than likely where the client and the server are located, we use IPv6 transition protocols to do that. the public IP address is used for that transition protocol, whether that be 6-to-4 or Teredo or IPH-TTPS. IPH-TTPS is the most common, of course. However, the actual communication to the client is within that tunnel, and that is done using IPv6. So in order to do this, the firewall rules on the client would be provisioned to accept traffic internally, or inbound, I should say, from the internal subnet. So you would use your internal, most commonly RFC 1918 private IPv4 address space, but you would also, if you've enabled managed out, you would use your corporate ISATAP prefix for the source IP address for that traffic. Alternatively, if you have deployed IPv6 on your network, which is not terribly popular these days, but if you have, then you just use your corporate IPv6 prefix as the source IP address for that rule. And the routing is done using just IP routing, whether it's IPv4 or IPv6. It really doesn't matter. It's just using standard routes. The DirectAccess server functions as an ISATAP router, so if you've deployed manage out and you just have IPv4, then you can deploy a service known as ISATAP to enable that communication to take place, initiate outbound communication to DirectAccess clients from the DirectAccess or from the internal network.
Great. The next one is from Isam, is how fast is upload download speed for DirectAccess? And can you monitor traffic and disable users?
So the first question, how fast is it? That's a difficult question to answer because there are a myriad of determining factors that go into that. Where the DirectAccess client is located, how heavily loaded the DirectAccess client and the DirectAccess server is, which transition protocols are in use. Those types of things. There's a variety of things that go into that. Typically, it's not bad. It's no different, or probably it's no better or no worse than using a regular VPN. We're using fundamentally the same underlying mechanisms, IPsec encrypted traffic. So IPsec does include some overhead. There is overhead in managing security associations and doing the encryption and decryption and so forth. So it's obviously not going to be LAN speed, of course. And of course, your internet connection enters into that, factors into that as well. So there's a lot of things that go into that. But again, I would say it's not going to be any better or any worse than any traditional VPN. Of course, you can monitor traffic. There are native tools available in the management console to determine who's connected, what they're connecting to internally. And disabling users is actually, there's a variety of ways to do that. So the direct access connection is fully authenticated and encrypted, as I'd said before. The authentication happens at two levels. It happens at the machine level and it happens at the user level. So disabling users is pretty straightforward. If you don't want a user to connect via direct access, you can disable the user. Now, of course, that means they won't be able to log on through regular VPN, means they won't be able to log on if they're on the CorpNet either. So that might be a bit heavy-handed. If you simply want a specific machine not to be able to connect via direct access, you can certainly do that. Unfortunately, there's no native tools in the UI to handle that, but there are some PowerShell scripts that you can find. You can find those actually on my website, directaccess.richardhicks.com, that will basically the PowerShell goes through, searches for the computer, and then will disable the IPsec tunnels. It actually deletes the IPsec tunnels. Now, if you want to prevent them from reconnecting, because direct access will just attempt to reconnect, what you can do is disable the computer account, disable or delete. Disable the computer account before you do that. Then when you terminate the security associations, those IPsec tunnels, when they attempt to reestablish, they will not be able to reestablish because the computer account in Active Directory will be disabled, and so the authentication process won't take place.
All right, we have a couple more questions, and I think we have time. So let's look at the next one. Daniel's asking, what is exactly the disadvantage of a broadcast-based NLB? I think this goes back to us discussing the advantages earlier.
Sure. NLB is not really designed for large enterprise scale deployments. It is actually a very crude and very rudimentary type of load balancing. And as I'd mentioned before, it's not even really load balancing, it's more connection distribution, right? Network location, NLB uses broadcasts for heartbeat communication. So all of the members of the array of the NLB cluster communicate to each other with broadcasts, and those broadcasts happen every second. So as you have more and more members of the array, you have more and more broadcast traffic. Now, broadcast traffic, of course, goes out to all hosts on that segment, on that particular segment. That can be really challenging if you haven't designed your physical network infrastructure properly. So you can mitigate this challenge by creating very small segments, right? So in other words, if there's a network segment that only includes the network load balancing hosts, then the broadcast-based traffic doesn't really bother anybody else. But oftentimes, we deploy these in flat networks or somewhat flat networks, and so all of this traffic goes out to servers and workstations and network devices, and so it gets really, really noisy. The biggest challenge is that, of course, NLB being broadcast-based has negative scalability. So as we add members to the array, I generate more and more broadcast traffic, which is detrimental to the health of that particular segment. It introduces, overhead and increases latency, causes other problems as well. NLB lacks any sort of visibility, so it's very difficult to see, who's connecting to where, how healthy the cluster is. There are some tools available to that, but I mean, again, they're pretty limited in usefulness. NLB lacks any sort of application awareness. It has absolutely no idea if anything above layer 2 in the networking stack is available to it. So for example, direct access could be completely gone. In other words, as a matter of fact, the whole server could be down, but if the network stack is up and it responds to those broadcasts, then the NLB cluster continues to distribute connections to it. So it lacks any sort of application awareness or intelligence to be able to understand that, yes, the host is online, but it is incapable of handling these connections, so I'll need to route around that. That capability doesn't exist in NLB. And that's one of the reasons we tend not to recommend use of NLB in mid to large environments, because, again, fundamentally it's just not terribly effective.
Cool. Is there a separate license for direct access? I think we answered that question. It's not. It's just based on your Windows version,
it's not.
correct?
So that's correct. So basically, on the server side, it's a part of Windows Server 2012 R2. So if you have an operating system license, you have the ability to deploy direct access. Direct access clients are just provisioned as a part of the operating system. Again, there's nothing that needs to be done there. As long as your client is licensed and you purchase those licenses from Microsoft, you have the ability to leverage direct access. And this is a pretty compelling use case. We have a lot of customers, and certainly a lot of customers that I work with, large enterprise customers that can save substantially on their remote access licensing. So it allows them to eliminate or at least significantly draw down on client-based VPN licenses for their users and eliminate some costly and expensive infrastructure as well. So the advantage here is that it's always easier to deploy some Windows Server 2012 boxes on Hyper-V than it is to buy, proprietary dedicated security hardware and deploy it, on a network, and that requires, again, proprietary management skills and so forth. So there's significant cost savings for a direct access deployment as well.
All right. I think the next question's for me. It's about sizing. How can we size which model of LoadMaster will be required for load balancing and reverse proxy function for Link and Skype for Business? That actually is a bit more complicated than saying for 1,000 users use Model A and for 20,000 use Model B. The reason being, for Link and Skype for Business, it depends on the modalities being deployed, the workloads, and the common factors of how the sharing and the conferencing and other functionalities being used. It isn't something that we can very easily predict, so it has to be something that we have to work with every customer on case-by-case basis to size this properly. So I invite you to have a dialogue with Kemp employees, and we can help you out there. Next one, Richard, is DirectAccess with Windows 10. What replaces NAP?
Good question. Unfortunately, nothing replaces NAP. So this question is alluding to the fact that NAP, or Network Access Protection, in Windows Server has been deprecated by Microsoft, and it's actually been removed from the operating system beginning with Windows 10 and Windows Server 2016. There is no native Microsoft replacement for that. There are most certainly third-party solutions that can replace NAP, but to my knowledge, none of them integrate with DirectAccess specifically. I may be wrong on that. Again, I'm not a third-party NAP expert. I'd love to talk to somebody more about it and see if there's a way to make that work, because we do have a lot of customers, especially in Europe and UK, that have deployed NAP. It doesn't seem to be as popular here in the US, but in Europe and UK, it seems to be more widely adopted, and we're having a lot of customers that are asking those same questions. So today, unfortunately, I don't have a good answer for you. The answer today, the short answer today, is that there isn't anything that replaces it for direct access integration. Now, there are solutions, again, that will replace it, but not that I'm aware of that specifically address the direct access enforcement point.
All right, perfect. Next one, again, I think that's for me. What's the preferred way to deploy DirectAccess plus Kemp LoadMaster across 2 nearby data centers, which has unlimited stretched VLANs between them? Maybe from DirectAccess perspective, Richard, if you want to address that.
Yeah, from a DirectAccess perspective, again, if it's stretched VLAN, then that's pretty straightforward. DirectAccess servers in a cluster must be on the same subnet, so and that has to do with routing, because they're in shared routing tables. So as long as the VLAN spans data centers, they are effectively just like just like any other deployment on a subnet. You would have a couple of DirectAccess servers. They would be a part of a virtual service running on the Kemp LoadMaster, and you would just use the source IP address or the internal IP address of the DirectAccess server as the pool member, and you'd be good to go.
And that also comes down to deploying the LoadMaster in similar fashion, because if you have, usually you always have a pair. You don't want the load balancer to be a single point of failure, so you're going to have a pair. If you're going to span the subnets, then you could potentially use a pair across the 2 data centers if you want to make it cost effective. We have to account for the latency and other factors to make sure that it's viable deployment, but it's possible. All right, next one is any documentation guide available to know the direct access workflow, authentication, etc. And that's not the load balancing guide. It's more about how the direct access works, I think. So, Richard, do you know of any besides, I guess, Microsoft TechNet itself? That's pretty detailed, isn't it?
It is. I don't know that it is. It probably is. I'm not certain that I've seen that, though. I'll be honest with you. That is an excellent question, though. I'll have to probably take that one offline and do some research on it. My gut feeling is that it is documented somewhere on TechNet. The challenge will be, of course, finding it, 1, and 2, determining the quality of that documentation. That may be something that would be good for me to document and put onto my website, because it's probably would be a good reference document. But to my knowledge, I don't know specifically, but I expect that it does. So that would just be a Bing search for those out there that wanted to undertake that effort.
Awesome. And I guess that also means we will see some more useful documentation from your blog.
Yeah, and that's what I generally use the blog to do that. As people ask me questions, and as and when I can't find that information on the internet, or they can't, those obviously become points that I will try to address and try to make that information available to folks.
Yeah, that's great. Thanks. And so the next just couple left, so I think we're coming up on closure as well. How do we manage out DA clients if we have Server 2012 direct access environment?
So it was Windows Server 2012 and 2012 R2 are functionally identical. So there's really no difference between Windows Server 2012 and Windows Server 2012 R2. That being said,
so you can manage out the same way.
That's correct, yeah. But that being said, and I think this is a good point, is that it's important to know that there were many bugs in Windows Server 2012 DirectAccess that were fixed in 2012 R2. So if you're deploying DirectAccess, always advisable to deploy DirectAccess on 2012 R2. ISATAP manage out. So manage out is easy if you have IPv6 deployed on your corporate network. It's basically just a matter of configuring routes to get that traffic back to the DA server to get it out to the clients. If you're still using IPv4, you can use ISATAP manage out, which allows you to talk to the DirectAccess clients from an IPv4 network. ISATAP is not natively supported using DirectAccess when it is configured in a multi-site or when you're configuring it with a hardware load balancer or an external load balancer, I should say. However, as I demonstrated earlier in the session, it is possible to do that using a bespoke configuration. If anybody has any questions, I would suggest that they reach out to me directly, and I'd be happy to provide them some more detailed information on that.
Okay, and I think I'm going to take the last one now. We're at the top of the hour. Can you confirm what forest and domain function level is required for DirectAccess?
Yes, absolutely. So Windows Server 2008 is the minimum. Also, it's important that because this guidance recently changed, just recently. Previous to that, it was Windows Server 2000 or Windows 2003. Microsoft recently updated their unsupported configuration document to include that. So Windows 2008 is the latest supported. Also, they don't. You have to be using DFSR. You can't be using the old version. I forget what it was called. But anyway, the domain replication, sysvol replication has to be done with DFSR now.
Okay. All right, cool. There are a couple other questions, but I would invite you guys to connect with us offline afterwards. We'd be happy to answer the questions. I know we are running a file on time if we continue going. So unfortunately, we have to stop here for the questions. I hope we helped you answer most of them. I know we have only 2 pending right now, so it's not too bad. Richard, anything you want to go with closing, and we'll turn it over to Liz.
No, what I would say is if you have any questions about the Kemp platform, be sure to visit kemptechnologies.com. Free trials, videos, sizing guides, as Bhargav alluded to, are there. Information about load balancing other workloads as well. And then, of course, for direct access related information, directaccess.richardhicks.com is your source. So thanks, everybody, for joining the webinar today.
All right. Thank you, everyone. And we'll close the webinar at this point.
Very good. Thanks, everybody. Thanks, Bhargav.
Thank you, guys. Thank you, everyone, for staying with us and listening to our webinar. A recording of it will be available hopefully by the end of next week, if not earlier. All right? Have a great day, everyone.